All right, so for our next lesson, we're going to go over section 7 and section 8, which is all of our word problems for our exponential and log equations. So the first formulas that we're going to look at are our financial formulas. So the first formula here is A equals P. You guys can read it, right? So let me start with P actually. P is the amount that you're going to invest, right? So you're going to go to a bank and you're going to invest $100, okay? So P is the number you're investing. R is the rate, of course, expressed as a decimal. Now, N is the number of times it's compounded. So if it's compounded quarterly, that would be 4 times a year. If it's compounded daily, that would be 365 times a year. If it's compounded twice a year, then that would be 2. Okay, T is then the number of years. Now the difference between these two formulas is that P is still going to be the amount you invest, but this time for this formula we're doing continuous compounding. So at any moment of time it's being compounded, compared to this is saying on March 1st it's going to get compounded. This is just at any moment of time it's getting compounded. It's continuously happening. Okay, so you have to pick the right formula based on how many times it's being compounded. Now, A tells us the amount that we would have in the bank. So if I invested $100, then after all of this, I now have $200. So A is the amount I have after so many years. The effective rate of interest is found by these two formulas. This is if it's compounded n times a year, so it would match with the first formula. This is continuous compounding, that would match with this formula. Okay, we'll talk more about that when we get there. Now, present value formulas is going the opposite way. So essentially what these formulas are saying is, okay, I know I need to buy a car. Okay, in 5 years I want to buy a car, and I know the car is going to cost me $6,000. So how much do I need to put in the bank now so that in 6 years I have $6,000 or whatever it might be? Now the only difference between these formulas is that the A and the P switched and that we have a negative exponent. So the A and the P switched spots, which in return makes the exponent negative. Okay, so for example, Mrs. Sotomayor is investing $300 at 7.5% for 4 years compounded quarterly. So because it's compounded quarterly, we're going to use our formula A equals P times 1 plus R over N to the NT. Yes, you have to know these formulas for the test. Okay, you've got to memorize it. So she's investing $300, so that would be P. 1 plus the rate is 7.5%, so as a decimal, that would be 0.075. Now, N is the number of times it's compounded. So if it's compounded quarterly, that would be 4 times a year. To the N times T, and the number of years is T, so 4. So now let's plug that into our calculator. So use the fraction button, 300 times 1 plus fraction 0.075 divided by 4. Oops. To the 4 times 4. That gives us 403.83. Now I know in math we always round to 2 decimal places, but if we're talking about money, we're only going to do 2 decimal places. Now the question didn't ask how much she'll have in 4 years, it's saying what interest did she earn. So this is, she invested $300, she now has a total of $403. So that means the interest that she earned would be 103.83. That's the amount of interest she earned. She put in $300. This is how much she has now, so she gained $103. Okay, now example 2 here, this time it's being compounded continuously, so we're going to use PERT. P-E to the R-T, PERT. So now Jack is investing $500, at a rate of 6.7%, which would be 0.067 for 6 years. Find the interest gained. So once again, we're going to plug that into our calculator. 500 e to the so he gained an interest of $247.41. That's the amount that he gained. Okay, so great grandma Rosie placed $3,000 in an IRA for young Jose on January 2nd, 2007. It is paying 7.5% per alum, compounded continuously. What will the IRA be worth on January 1st, 2022? Okay, so because it's compounded continuously, that's PERT. She went to the bank and placed $3,000 in it. The rate was 7.5%. Okay, now to go from 2007 to 2022, that would be 15 years, so the time is 15. So plug that into our calculators. So she now has 9,240.65, right? So that grew a lot in 15 years. Even though Great Grandma Rosie only put $3,000 into an IRA, in 15 years, Jose could have that much money, right? So it grew by almost $6,000. Now the second question is saying, what is the effective annual rate of interest? So that formula, if you look on the other page, because we're compounded continuously, the formula is e to the r minus 1. So e to the r minus 1. So e to the rate minus 1. So the effective rate would be 7.8%. That would be the most effective. Okay, number 4, find the present value of $200 after 3 years at 5% compounded daily. So what this is saying is if I want $200 in 3 years from now, how much do I need to invest now? So in this problem, I'm trying to figure out what is P. What do I have to invest now in order to have $200? So that's when our A and our P switch, and we now have P equals A. Now compounded daily means our formula is this. But because the A and the P switched, our exponent is now negative. So I want to have $300 at a rate of 5%. Compounded daily would be 365 times a year. To a negative 365, the number of years would be 3. So plug that into our calculators. 300. Okay, wait, I messed up. We only wanted 200. I don't know where I got 300 from. Let me fix this. Sorry, guys. There we go. 172.14. Okay, so if I want $200 in 3 years, then right now I need to make sure I put away 172. So it's not going to gain that much after 3 years. It's only going to gain about $28, which isn't really a lot in 3 years. Compounded continuously, find the present value. So P equals A, so 1,000. Because it's compounded continuously, we have e to the r times t but because we switched a and p, we have to make the exponent negative. So $704.69 we would have to invest now so that in 5 years I have $1,000. Okay, number 6 says, how long does it take for our money to double at 4.5% compounded quarterly? And I also want to know how long would it take for it to be compounded continuously. So we're going to have to do 2 different problems here. So quarterly and continuously. We're going to do the problem twice. So let's do compounded quarterly first. So we've got A equals P times 1 plus the rate, which we know is 0.045. Compounded quarterly would be 4 times a year to the n times t, and I don't know what t is, right? That's what I'm trying to figure out. How long? What's the time? How many years? So if I want my money to double, if I invest P dollars and I want it to double, then I'm now going to have 2P amount of dollars, right? Because I don't really know how much. I'm just saying in general, if I need it to double, whether this be $100 or $1,000, I want it to double. So I need to use my algebra skills to solve for T. So my first step is this says P times those parentheses, right? So to undo multiplication, we use division. So I'm going to divide by P on each side. So that gives me 2 equals 1 plus 0.045 over 4 to the 4t. Well, we learned that when we have an exponent, right, then we need these bases to be the same, but I cannot make this and this the same base. So I'm going to have to use logs here to figure this problem out. So remember, the base stays the base. So we're going to have log base 1 plus 0.045 divided by 4, and then the 2 and the 4t switch spots. So 2 equals 4t. Now divide by 4 to get t by itself, so I'm going to divide this whole thing by 4. Now t is by itself, so I can plug it into my calculator. So I'm first going to do math log base of 1 plus fraction 0.045 divided by 4 of 2, and then I need to divide that answer by 4. I get 15.490 when I round. So it's going to take me about 15.5 years to double my money with these parameters. No matter how much money I put in there. If I put $10 in, it's going to take me 15 years to get $20. If I put $1,000 in, it's going to take me 15 years to get $2,000, no matter what amount, in order for it to double. Now we're going to do the same thing with continuous. So I want there to be double the amount of money that I put in, but this time our formula is e to the r, and I don't know t. So same thing, I'm solving for t. So same thing, this is P times E, so undo division. What am I writing? Now once again, to undo this, I'm going to have to change it to log, so the base stays the base. So this is going to be log base E, which is just ln, of 2 is equal to 0.045 t, divide, ln of 2, parenthesis, divided by 0.045, gives me 15.403 years. So the continuous is going to be a little faster, but not a whole lot faster, right? It's not going to be a lot faster, but a little bit faster to do the continuous.